This podcast is on the mole and molar mass and the beginning of chemical calculations. Why the mole? Well, chemists need to be able to count atoms and molecules, and those atoms and molecules are really small. So you can't really count them one at a time by hand. You know, dairy farmers count eggs by the dozen, and other industries have other counting numbers, and chemists have their own. It's something we call the mole. The mole is a counting unit, in other words. It's a really big number, 6.02, and all those zeros, which in scientific notation is 6.02 times 10 to the 23. We don't really use it that often, just we need to know that in every case the mole is the same number. You see, it's named in honor of Amadeo Avogadro, who studied quantities of gases and discovered that, well, it didn't matter what gas there was. If he had the same volume, he had the same number of molecules present. He never really found the number. But, you know, we still need a way to count, and chemists use mass to count atoms and molecules. You see, you can use mass to count. If you have a bag of mini M&Ms and you know that the average mini M&M has a mass of 0.89 grams, you can count them by mass. Let's say the mass of a bag of mini M&Ms is 33.15 grams, and the bag alone has a mass of 2 grams. How many mini M&Ms are there in the bag? Well, 35, right? Okay, here's how we did it. And my guess is some of you have already done it. The mass of the mini M&Ms alone was subtract the mass of the bag, and you get 31.15 grams. And the number of mini M&Ms in the bag was, well, just divide by the mass of one M&M and you get 35. That's how it's done. Chemists do the exact same thing. But we need to use the mass of the mole of our sample, and we're going to use an average mass of a mole. And chemists are quite clever. They set up things so that the values on the periodic table are the mass of the mole of the atoms. For example, hydrogen in the upper corner has a mass of 1.008 grams for 1 mole, and that's called the molar mass. So, it's the mass of a mole of a substance. It equals that numerical value. It's from the periodic table, and there's 3 examples. Carbon, if you look it up, you'll see 12.01. Magnesium, 24.31. Copper, 63.55. And there are obviously 100 plus masses there. We use it to count. Okay? So the mass in grams of a mole is equal to the value, to the sum of the atomic mass of a compound. Okay? Let's say we had mole nitrogen monoxide. You remember nitrogen monoxide is NO. Well, as you go through and calculate, you'll discover that when you add them together, the mass of 1 mole of nitrogen monoxide is 30.01 grams. Likewise, if we happen to have calcium chloride that has 2 chlorines in it, you will multiply the Cl 35.45 times 2, and we get 110.98. The same is true for something like dinitrogen tetroxide. Again, 2 moles of N, 4 moles of O, multiply it through an atom. If you end up with compounds in parentheses, like this calcium phosphate, okay, you do it the same way, and in moving through it, we end up with remembering to distribute that little 2 to the p's, so you have 2 p's, so 2 times 30.97, and 2 times 4 are 8 O's, and we end up with 310.18. Okay? These molar masses are very useful because we do calculation with them. We use balances in the lab to measure the amount of matter we have, and then we calculate moles using molar mass. You can go from grams to moles using molar mass, and you can obviously go backwards from moles to grams using molar mass. An example. How many grams aluminum are in 3 moles of aluminum? Well, you need to do a conversion, right? Molar mass of aluminum, you go to the periodic table, it's about 27. The setup is pretty straightforward. 3 moles of aluminum times 26.98 grams of aluminum in a mole. The moles are going to cancel, and you're going to get your answer, which is 80.9 grams of aluminum. That's going one way. If we're going back the other way, silicon dioxide, how many moles are in 68.57 grams? So in order to do this problem, first of all, we need the molar mass, and you go to the periodic table and look up silicon, look up oxygen, add them together, If you're just doing it quickly, 60 grams. If you need more decimal places, 60.09 grams. And then the setup is, as we did for the M&Ms. Multiply it by 1 mole over 60.09. It's the grams of silicon dioxide cancel, and you get 1.141 moles of silicon dioxide. So as I hope you've shown, you can use molar mass to go between grams and moles of material. And since a mole is the counting unit of chemistry, we don't really need to worry ourselves with individual particles.